This semester. It's offered as part of the Data Science Institute, as well as through the EPSCoR Change Hawaii program, a couple of other. They have faculty from part of the Change Hawaii research, also part of the cyber infrastructure group that are collaborating to present a workshop today on the Hawaii Climate Data Portal. First up, we have Matt Lucas, kickstart the workshop. Folks, if you didn't get a chance to look at the HCDP quick start cheat sheet, we put that in the Zoom. We've also emailed that to you, but if you need additional links, feel free to unmute yourself or put it in the chat and we can reach out with any questions and help. Thanks, Matt.
Okay. Hi, everyone. I am Matthew Lucas. I am a climate data analyst on the Hawaii Climate Data Portal. I started working on this project before we knew it was going to become the Hawaii Climate Data Portal, about 6.5, 7 years ago. But yeah, today we have a pretty full agenda, and we're going to give a little background, and we're also going to give a show you a couple different ways you can interact with the data. So just to jump right in here, our agenda, the agenda of this is welcome and setups. That's kind of where we're at right now. Dr. Ryan Longman is going to give a HCDP introduction and kind of the history. And then I'm going to go through the data that's on there, a quick website tour of everything other than the data access parts, and then briefly go over the different data access methods. Then Dr. Carrie Kodama is going to do a GUI data portal visualization, so walking through how you can access the data in a web GUI interface. And then we're going to do some GUI exercises kind of to get you interacting with the data yourself. Then we'll shift gears into the using the API code. So we'll be introducing the API code link that's on GitHub. We'll have the time for some token setup. There should be a token that was sent out to everyone in an email that is a learning token, a temporary token. And then we'll also talk about the cheat sheet. And then we'll jump into some API examples with Jared McLean, who is online. And Sean is here in person to help us assist with those. Then we'll do some API exercises where you kind of have to maybe solve a couple of API solutions yourself. You should be able to do this with the examples that are given in the cheat sheet. But if you can't, we'll end up showing you how they actually work. And then we'll go into some more HCDP resources, do the survey, and have time for questions. So right now, just to start, this is where we're at, welcome and setup. We're going to move into the HCDP introduction with Ryan Longman.
Hey everyone, thanks for being here. I'm Ryan Longman. I work at the Pacific Islands Climate Adaptation Science Center. I thought it'd be good. I know you're here, ready to learn about data and getting, accessing data, but I think it's good to kind of be grounded in this space and understand what it took us to get here to be able to do a workshop like this. So I'm going to give you a quick 36-year history of the Hawaii Climate Data Portal, and it started way before we had the acronym. It started way back in 1986 with the first rainfall atlas developed by Tom Giambaluca, and we started deploying some stations. Not me, because I was in middle school at this time. On the slopes of Haleakala, developing a network there. Other networks were developed between 2005 and 2012. So this period from like 1986 to 2012 was this period of kind of starting to collect data in Hawaii, starting to figure out how to store it, how to quality control it, just kind of getting our feet wet. And I was involved in this process here in the later part of this. Then we started developing gridded products. It started with the 2013 Hawaii, the Rainfall Atlas. It was an update to the original Rainfall Atlas. It was an online web tool. And then we had the evapotranspiration atlas with a bunch of other climate products. These were climatology, so 30-year means. Then the first set of month-year maps, 1920 to 2012, were developed by Abby Fraser in 2016. And then we had a kind of an inventory of what was going on, what stations were available a couple of years later. Then we started creating daily rainfall maps and daily temperature maps. So this period right here was a time of really kind of figuring out how to map climate in Hawaii, how to do some things like gap filling, and then the product development, right? Like developing these gridded products. But what we realized is every time we were creating these maps is that they had a finite end date. So, for example, the daily maps, they went to 2014, the paper was published in 2019, and the first question was, well, what about yesterday's map? And so everybody wasn't interested in something that was 5 years ago. So we knew that we needed to find some way for product automation. So the first EPSCoR, as of EPSCoR, this is the second version of that. They came to us and said, what do you guys want to do? We said, we want to make these maps come out in near real time. And they were like, all right. So we just went for it. We hooked up with the cyber infrastructure folks, and we started figuring out a way that we can start producing these gridded products and have them in a way where they were available in near real time. So on March 3rd in 2022, we officially launched the HCDP. We got it working hours before the actual launch. It was kind of a photo finish, but since then we've been going strong. And what we're doing with HCDP is grabbing all of the data that's around that we can get telemetered, and then using it to interpolate and create these gridded products. And then they're being stored on the HCDP every day at midnight. The workflow executes, and then we store those maps. So today you have access to yesterday's rainfall map, yesterday's temperature for the daily, and then last month's temperature and last month's rainfall for at the monthly time step. And we have other daily products and sub-monthly products as well. So Matt Lucas published his methods for the rainfall mapping. We continued to work with the EPSCoR project to change Hawaii, a second version of this. Kerry Kodama published her temperature maps. So this period was more about building kind of the cyber infrastructure to capture all this data and to store it, about getting the automation workflows going, and then publishing methodologies. And now we're into this new stage here. We have more data coming in through the Hawaii Mesonet. It's an effort to have 100 climate stations reporting data in real time. And then we're also developing a ton of tools and resources and working with partners to make this data accessible to a wide range of applications and to people. So this period, this kind of final period that we're in right now, derived products, decision support tools, and looking at more and better data. And that's what takes us to the point here where we're have done all this work, and it's why I'm showing you this. It took us 36 years to get to this point where we can now open it up and say, hey, you guys can access the data, you can answer the research questions, you can build cyber infrastructure to develop your own tools. So this takes us back all the way to the beginning, where if we didn't have measurements and high quality measurements, we wouldn't have any of this. So it's really important that those measurements, they led to this eventual workshop. This is just a quick snapshot of the key players here for the HCDP. So I'm at UH at the PyCast. We have Matt Lucas, who's teed off here, the Water Research Center. Kerry Kodama's at the East-West Center. Sherelle Hughes at UH. Amy Schreiber, she does the communications. And then we have the cyber infrastructure folks, Sean Cleveland and Jared McLean. So we have this kind of real nice relationship between climate science and the data science folks. And then Tom Giambaluca, he spearheads the Meso Network and the HCDP. So anyway, welcome everybody. I'm really happy you're here. Hope you get something out of this, and hope you feel a little more grounded now in what it took us to get to this point. I know you're here to learn some technical skills, and I encourage you to dig in and learn those things, because there's lots of applications and things that we can do with this data. So passing it back to you, Matt.
Okay, thank you for that, Ryan. So we got a little history there, where the HCDP came from, and now we're going to just kind of talk about what it actually is. So the data, a quick website tour of everything other than the data accessibility, and then I'll introduce the different ways that we actually look at the data. So what is the HCDP? Well, it stands for Hawaii Climate Data Portal, and it's a web-based climate data access platform. And it hosts and produces historical and near real-time high-resolution climate maps for Hawaii. It also offers data through interactive API, so application programming interface, and batch data request. That's through the GUI. We'll learn that in a minute here. It hosts recent climate-related projects and publications. It also is intended to be a one-stop shop for Hawaii climate data access. Finally, it's very cool and it's free. So this is the website, the Hawaii Climate Data Portal. It is found at www.hawaii.edu/climate-data-portal. And now I'm going to just go in and give you a quick website tour. Okay, so this is the, this is the landing page of when you put in that URL, this is where you'll get. First thing you're going to see is these maps. These maps are just visual display, and they're toggling through yesterday's temperature and last month's rainfall. So this is, you know, the temperature, the min temperature, the max temperature, the mean temperature, and last month's rainfall. We could update this and actually include yesterday's rainfall as well, because that is now a product that wasn't a product when this was created. But essentially, this is just to kind of show and fill some space, and also it's handy for us to just as a quick check to see that the data actually produced. So in your home thing, that'll obviously get you back home here. In the About tab, we have the team, which we already went over, the HCDP history, which we already went over, rainfall mapping history, a little bit more in depth about how the different data sets kind of came to be, climate monitoring history, which is kind of, will also go in depth into the different networks of stations in Hawaii, some acknowledgements, and then the most important is how to cite. So that if you look at the how to cite, it'll actually give you the different papers that have been published about the different data sets and how you can actually cite those. So if you go into the next tab over, it's data portal. So there's access data. This gets you to the same place this big blue button gets you to. So Carrie's gonna go in depth into that. So we're gonna skip that for now. There's also a data portal for the Hawaii Mesonet. So there is a right now, if you click this, you can get to the data, the information about the, or no, sorry, this is API access. So this is actually where you can sign up for the API and get your own token, which we'll be using a temporary token for today. So you don't need to worry about that for today's training. But if you want to use the API in the future, this would be this location, the data portal and HCDP Hawaii Mesonet API is where you can actually sign up to get a token. Then we have a few tutorials on here. So there's different tutorials, but these are all tutorials with using the GUI interface, which Carrie's actually going to go through a lot of this. And then again, another website. So the other tab we have is cultural resources. This is got a bunch of really interesting and educational stuff that has the Native Hawaiian perspectives on climate, and as well as a bunch of really cool archived newspaper articles, the moon calendar, that's a very popular part of the site, some educational resources, a climate glossary, so you can kind of understand, you know, have different climate terms. This is all really good for educational purposes, but also cultural purposes is pretty interesting. And then we have the library here. The library allows you to search. It has an index. We try to keep this up of different climate papers. So you can do a search, or you can do a subset of cultural resources, different precipitation summaries. So this is another resource. It's just access to all the papers that we have collated and the papers that we've published on this. And then finally, you have some climate tools. And the climate tools are, right now, this is the Rainfall Atlas of Hawaii is actually down. So we're rebuilding that. That's a really popular previous effort that we did. Unfortunately, the server for that was the program that was running on the server is out of date. And so we are completely rebuilding that from scratch. We also have these site-specific drought knowledge exchange portfolios that we're going to have more functionality of that in the coming year to be able to do a custom, be able to get a custom report automatically generated about climatology and land cover and cultural resources, some cultural knowledge about any specific site in Hawaii. So that's look for this to upgrade. We have the Hawaii Rangeland Information Portal, HRIP. So that's a pretty cool one that's looking at different cattle ranching areas and relating them to real-time climate. So we have a bunch of partnership with cattle ranchers in there. We have the Hawaii Groundwater Recharge Tool. That was project that Jared worked on previously. It shows different land covers and different land cover scenarios with different recharge potential. Coastal erosion is another group at UH. Sea level rise viewers, another group at UH. Climate in Hawaii is another page that we built that we're rebuilding. And yeah, so there's a bunch of different climate resources here. But if you go back to the home page, we also have the Hawaii Mesonet. So this is where you can actually get information about the stations that are in the Hawaii Mesonet that are being deployed. There was a news article about that recently. And then we have the Pacific portal, which we're also building out. And then again, for these, this is some more of some of the more popular climate resources like the Rainfall Atlas, Evapotranspiration Transpiration. These are being rebuilt. There's some functionality you can download the data, but you can't interact with the data on that. So yeah. Whoops. We're right here. Okay, so what is actually on the HCDP? You're gonna be interacting with the data with Carrie, but just to give you a quick understanding what's actually on there, we have surfaces. So this is wall to wall between all available stations. We have estimates of different variables. So these are county and statewide extents. They're in the GeoTIFF format. They're 250 meter resolution, and they're in WGS 84 decimal degree projection coordinate reference system. We also have station data. So we have station data on the HCDP that is daily, aggregated to daily, and aggregated to monthly. And you can see the stations that were used to make a map if the map used stations to make it. We also have metadata. This is usually overlooked, but there's a lot of really good information in this. This is text tab delimited, which makes it human readable. We also have generate an automatic statement for a lot of the products to tell you the quality of the product and how it was actually made. And then we have a whole bunch of leave one out cross-validation error metrics in the file itself. These get downloaded automatically when you download a surface. Okay, and then products themselves. We have rainfall. So we have daily and monthly rainfall. We use a climate-aided interpolation or ordinary kriging. And we have historical, so going back monthly and daily, 30 years. Actually, monthly goes back to 1920, but that data set stops in 2014, and there's an overlap period. So there's two different rainfall data sets that are monthly, but there's one that's real time. And then we have a contemporary historical climatologies and contemporary climatology. So that's mean annual rainfall, mean monthly rainfall, those kinds of things that are made from different data sets. And we have documentation of what each one is. We also have min, max, and mean air temp. So that's also available at a daily and monthly time step. It is using a linear regression with elevation primarily. And we have historical and contemporary climatologies available with that data as well. We have relative humidity. So it is daily, but it is basically a midday approximation of relative humidity, because relative humidity does change by the hour, but we wanted to start with a daily product. And that uses a linear regression with dew point temperature and max temperature. And then we also have NDVI, which is normalized difference vegetation index. It's a 16-day composite, and we're using MODIS, and we use a Google Earth Engine process to actually produce a 16-day composite for every day, so that each day will produce the past 16 days, the composite of the past 16 days. And then we also have future climate projections. So we have future mean annual and seasonal rainfall and temperature available for statistical and dynamical downscaling. These are two different methods. We have a mid-century available that's just in statistical, and we have a late century for both types of methods. And we have those for RCP 4.5 and 8.5. So we also have some new products that are going to be coming out over the next year. We have, wind, mean and max daily wind. That'll be an interactive map available on the website itself. And we have an hourly gridded wind speed and direction, which will probably be API access only. We'll be visualizing that at least right away. That should be coming out hopefully by the end of next month. We also have a couple of different fire probability or fire risk maps. So we have a fire probability map that is a work of Dr. Clay Trauernicht. And then we also have fire ignition risk probability, which is the collaborative project we worked on with Dr. Syed Batani. And then finally, we have some We have SPI, Standard Precipitation Index, a drought index. We're hoping to maybe have that out sometime in April 2025. And we also have solar radiation. So we're going to have a real-time solar radiation producing, and that should also hopefully be happening in April of this year. So now that I've showed you the data and what's happening, I just want to introduce you the three different ways you can access data on the Hawaii Climate Data Portal. And so there is interactive point data. So there's a way to interact with the interactive point data. There is batch data download. So you basically say you want a range of data for a location, for a county or statewide extent, and then you can download all of that batch or get it emailed to you. And then there's also the API code access. So to begin, we're gonna start with the interactive ways that you can do this, so the interactive point data, and then also move on to the batch data download request. So that being said, we're gonna move on to the workshop, and I'm gonna pass this off to Carrie. And she'll be doing a live demo. So if you go to the HCDP page and click on the access data, she'll guide you from there. Thanks, Carrie.
All right, thanks, Maddie. And just so everyone knows, we dropped a link to the HCDP in the chat. So if you didn't manage to copy down the URL from the PowerPoint, you can just find it in the chat. All right. There. Okay. So as Maddie said, there's a couple ways you can get to the data visualization and export tool. One is just this big blue button on the homepage, or you can go into the data portal tab and click access data from there. And that'll get you to this page where it's kind of split into two, where there's one section for the visualize data tool, and then one section for the export data tool if you just want to access the data in that batch mode that Maddie mentioned earlier. So I'm going to go into a tour of the visualize data section first. So again, you see that the screen, once you click there, it splits into two sections, and the left side is going to be the actual map visualization. And so it has, you know, the typical Google Map controls where you can click and drag it. You can zoom in on sections that you're more interested in. And then you'll see under the zoom area, there's going to be the, oops, that was a little too early. But if you click that little camera button, what it does is it generates a screenshot of whatever image of the map you have pulled up in that visualization section. And then if you were to click the download, it would just give you an easy access graphic that you can use, you know, for reporting or putting it in into your presentations. I've literally used it for hosted presentations for conferences to make easy graphics that way. So I'm going to have you guys go through that, making an image of a map yourself in one of the exercises. And then you see the label at the top that just tells you what variable you're on. And then in the upper right corner, there's going to be this menu that opens up, and that allows you to change the actual map visualization settings. So you can change the base map, so going from satellite to street view, for example, or this topographic style map. You can change whatever the map style you want. I'm going to stick with the satellite, which is how it defaults. And then below that, there's going to be a toggle so that you can turn off, if you just want the actual map, the gridded products visible on the map, then you can turn off the stations. And likewise, if you just want to see stations, you can turn off the data map if you're only interested in those. And then you can also, if the data map is on, you can change the opacity of it so that you can see the underlying terrain better if you're interested in that. And then lastly, you can change the actual color scheme of the map. It defaults to that one called Viridis, but you can change it to these different presets that we have, or you can even upload a custom one if you have a built-in custom color bar. So I'm going to go back to the original. Reset. Okay, So now on the right side, you start in this data set tab, and there's 3 tabs on the side that allow you to control different settings and information about what you see in this map here and get more information about the map. So the first thing you see in the data set section, that actually allows you to control what variables and products that you're visualizing and what time frame that you're visualizing them over. You can control the date settings up here at the top. And it's important to pay attention to this every time you change your data product, because, for example, you see here for the time period, this is showing monthly rainfall. But if you were to go to daily, hit submit, and always make sure you hit submit to actually change what you're seeing on the map, or else it won't change for you. Daily takes you to the same month that the monthly was on the first day of that month. So if you want to see the most recent daily, just make sure you change your date settings to go to the last date of the range. So just pay attention to that as you change your variables back and forth. If you're looking at different variables, make sure that you're actually looking at the date that you want. So just go back and check that every so often. So there's a scroll bar here that shows you the products that are available. So you can just keep scrolling through the list and see all of the products that Maddie talked about in his presentation. And also, I think, did we mention the climatologies?
Barely.
Okay, yeah, so you might have missed that there are climatology data sets that we've added here. And so each of these data products has, well, some of them have subproducts, and that will be in the second bar here. So for example, historical rainfall has just regular rainfall, which is the one that updates in near real time. It goes back to 1990, but then there's also legacy rainfall, and that's the data set that's a little bit older, and it goes back all the way to 1920, but ends in kind of an overlap period with the contemporary rainfall that it ends in 2012. So, and then like temperature, for example, there's minimum, maximum, and mean temperature, and relative humidity doesn't have any subproducts. So you just want to be able to like click through each of these things and check whether it has subproducts, what subproducts it has, and then checking the options that you have available. So the idea of this tour is to just make sure that if you're going on the HCDP on your own, you'll know what settings might be changing and what things change between each variable. And so you'll be able to fully explore the data set and change all the settings freely without, having to look up tutorials or, remembering things. You can just kind of explore the data on your own. And so similarly, the choosing the time period can affect what options you have available. So just make sure you go through all of the different drop-down menus, check out the tooltips and the hover text to help you navigate through the portal. So that's the data set settings tab. And then the next section is the location information. So you notice that if I have all the station locations pulled up on these dots on the map, let's zoom in a little bit to get a better view. You can select individual stations that you're interested in through this location menu. If you're interested in one particular station on the map, you can kind of find it based on the name here. I'm going to just click a random one, and then it'll pull up the information for that station on the map, and it'll tell you station name and the location and elevation and the actual variable value that you're displaying. The other way is you can just click on the map. You can either click a specific station, but you can also just click anywhere on the map and get the values, the map values at that location for any location, and these are called virtual stations. And the ability to do this is really handy if you go into the time series section, because you're able to, the tool will generate a full-on time series starting from the beginning of whenever the data are available all the way to the present, and it'll do this for daily and monthly data. And the nice thing about this is you can easily download that data with one click as a CSV. So then you'll download it and it'll give you a table of all of the data points that you see in this time series. And you can do that. You click this one for daily, click this one for monthly, and then, so that's just a really easy and quick way to interactively access the data without having to, do a whole lot of data processing on your own side. And then if you just want the picture, there's also, similar to the map, there's a little button here, that camera, and then it'll download this image as your own graph PNG that you can stick into your reports and stuff. And another feature of it is you can click and drag and select a subset of that time series image and then take a picture of that, so that if you don't want to show people the entire data series, you can just show the part that you're interested in. Okay, so I think that covers pretty much all of the features of the visualization tool. But what if you're just interested in getting the data for research purposes or assignments or anything like that? You don't really care about just having the visualization. So if you go into the export data tab, that'll take you to a pretty similar page to the dataset settings tab, where you again have all of your variables lined up here and you can select between them. And the controls are pretty much the same. You can, instead of choosing one specific date to view, you can choose a start date and an end date, and that'll give you the range of the data that you're interested in downloading. And again, choosing what time period you want available. Some data sets only have one type of time period available, so just pay attention to that. And then you're able to choose a little bit more specificity if you're interested in the whole state, or you can pick a specific county that you want to look at if you don't want the entire state map. And then there are two sections for the types of data. You can download the raster data, which is the maps, and then you can also download the station data as tables. And that's a little bit different from the station data that you would have downloaded from the time series tab that I showed earlier. So this one is going to give you all of the stations for the entire range of date times that you selected up here. So it's just like a little bit of a different way, and it's if you're interested in the whole data set versus just one specific point. So it's just different features to suit different needs. So yeah, I think that's about it. Feel free to explore this on your own. But right now we're going to quickly move into a little bit of a GUI exercise to see how comfortable, or to get you a bit more situated with working with the data. Where's the exercise?
Should be the, yep.
Oh yeah, okay. Okay, so the first exercise is gonna be just download a map of the daily mean. So I mean, like create yourself a screenshot using that screenshot tool on the map of daily mean temperature for December 4th, 2024 for any island of your choice. Just see if you can, select the correct data set, select the correct time period, select the date, and configure the map visual settings, and then actually set up the download. So I'm gonna give you a few minutes, or just a minute or so, and then I'll do a demo of what that would look like. Okay, I don't want to wait too long, so I'm going to start. I chose Oahu because I live here, and I'm back in the dataset tab, and we want daily temperature. So going to temperature and then finding the mean temperature subproduct, and then we're in the time period of daily. So making sure to click submit to make sure the map changes. And just as a heads up, the mean temperature product is one of them that does not use station data to produce the map. So you won't see station data for that one. So all we have to do now, we have the date chosen. And I'm going to zoom in a little bit. Let's do the screenshot. Oh yeah. Oops, I forgot to check. I forgot to change the date. So let's do it here. Okay. And so when you change the date, it'll automatically update the map for you. And then let's do it again. And so this is what you'd see when you download it. So hopefully you were all able to follow that. So we'll go on to the next exercise. Now we're going to focus on time series. So we want to look at a specific station, the station called Kalehua, and we want to grab monthly rainfall, and we want to get a screenshot of the plot, the time series plot. So let's go to the time series tab.
You gotta change this.
Yeah. Maddie's helping. Okay. So that would look like choosing rainfall, going back to monthly, and hitting submit. And because it's a time series, we don't have to choose a specific date, but we do want a specific location. So one thing that's nice is you can sort the data, the stations by field. So I'm going to search for the Kalehua station. Like that. And that gives us the station right there. And then we can click it on the location table to not worry about having to, click the right spot on the map. It gives us the map value for that day, but we want a time series. So let's go to the time series, and it's generated both the daily and the monthly time series for that location. So let's download that plot. And with one click, you have a nice figure of the monthly rainfall for that one location. Okay. So I'm going to quickly show you how it looks when you download the actual data. So if you click download as a CSV, then that will generate a table. And for all the dates in the time series, it gives you the value of the variable you selected at that location. And then you can do whatever you want with that, make your own plots or do analysis. And then last exercise, now we're going to the export data tool. We want to try and download a link for Maui daily relative humidity. And we're going to do it from August 1st, 2023 to August 10th, 2023. And we want to grab both the data map rasters and the station data from that. So I'm going to walk through that, but see if you can try to figure it out on your own and follow along. Okay, so remember the export data tab. We wanted relative humidity. This one's only daily, so I don't have to worry about changing that. And then navigate to the date range that you're interested in. So we said 2023. We wanted August 1st. Through the 10th. We want Maui, so we're gonna uncheck. Select Maui. And then click the maps so that we get the rasters. Click station data so that we get the station data. And then add files. So that allows you to, sets up the data set that you want to download. And you can actually add multiple sets of files to your download if you want. I didn't mention that earlier, I forgot. But yeah, you can actually download multiple sets of variables per download. So you don't have to like do a separate one for every single variable. But we're gonna just download this one. If the package is large enough, it's going to automatically check that you have to send it to your email, and then it'll email you a download link. But this one is small enough that if I put in my email address, click the license agreement, and then hit export items, then it will automatically download that data set for you as a zip. So yeah, just to recap, when you export data, you'll get this window. You can choose all of your variable settings, click add files, add more if you want to add more, and then put in your email and click the agreement and then hit export. And then you'll either get an email or an actual live download. What's that? Oh. Yeah, I mean, so the license just means that you're able to freely access the data and use it as long as it's not for commercial purposes. So yeah, it's just anything that's like educational, research, or personal use, it's completely fine to use for free, and you don't have to set up any extra agreements with us. But if you're doing anything for profit, then we need to have a negotiation with the team. So I think that's about it for the data access demo. Hopefully you were able to follow along with the different ways to access the data. And we're going to move on back to the next section.
Thank you, Carrie.
Okay, so next I'm going to go over a Python workbook on how to use the API.
Jared, yeah, I'll do it. Let me do a little introduction here. So
sure, sorry.
Yep, no worries. So yeah, Jared, like you said, he's going to be doing the third access, data access, HCDP data access, which is the API code access. And just a reminder, you were emailed, and I don't know if there's a chat, if it's dropped in the chat, there's a HCDP API calls quick start cheat sheet. So this has some of the variables that you'll be changing on here. It's 2 pages. Those are the 2 pages. I just am blasting through them now. You don't need to memorize this. Hopefully you can open that PDF up. Also, there's 2 links. There is a Google Colab link, which was also emailed to you. And that's where we'll be doing the coding, where Jared's going to be, you can follow along and actually do the coding yourself. And then there is an HCDP API notebook on GitHub. So when you go to that GitHub link, this is what it's going to look like. And the notebook there's the link to it right there. I don't know if that's going out in the chat or if people need that. Maybe ask in the chat. We'll try to get it in the chat if people need it. And this is where you'll click once you get there. So without further ado, Jared, why don't you take over screen sharing and yeah, go from here. I have the exercises too, so when you're ready to do the exercises, I'll take back over the screen.
Okay, so everyone should have received a token. But I'll drop the token in the chat. You're going to need that to access the API. Okay, so if everyone can go to Google Colab, so it's colab.research.google.com. You can just search Google Colab in Google and it'll come up. You should get a screen like this. You can go to where it says GitHub and then take that GitHub link that was sent and put it in there. And if you search for that, and click workshop.ipynb. that should bring up the workbook, and we're going to be just running through this, and I'll give a description of what everything's doing. So I'll give a minute for everyone to load that up. Once you have it loaded, the first thing that you're going to want to do is take that access token and replace this string with that access token. So where it says HCDP API token, and then where it says email, you'll want to replace that with your email address. Yep. And then everything else should run without modification. So we'll just run through it, and I'll give a description of what everything does. It might take a minute for all of the dependencies to install. So go ahead and run that first cell. That'll run any of the dependencies if you don't already have it installed in your environment. If you get stuck on anything or anything's giving an error, feel free to let us know, and we'll try to help you. So the first thing is just imports. So these are all the dependencies for the notebook. So run that, let that import everything. Okay, so next we're going to define the API token, your email address, and then this is just the API base URL. So everything is, all of the API requests are going to be off of this URL. And then a header, so you need an authorization token header to use any of the endpoints in the HCDP API. So this is just going to take that token that you set and create a header object from that. So the first thing that we're going to go over is how to create just an image in Python of the raster data. So this is going to hit the HCDP API raster endpoint, which basically will just take whatever data map you define and download the data for that. And then the rest of this is going to just create a plot in Python that illustrates that. So basically you give it a set of parameters, which is the data set that you're looking for, and then just some information for displaying it. So color ramp, what color you want for the node data values, which is all the background ocean cells. The endpoint for this API call is going to be the raster endpoint. So that's going to get appended to this. And then we're going to add on the URL parameters, which are going to be in this parameters object, which I'll go over later. Then it's just going to print out the constructed URL, create the request, and then it's going to create, you're going to create a plot using Plotly. And this is just some data to set the plot so that it looks nice, setting the node data values. And then we're going to read from that. We're going to open that using URL open, open the API endpoint, and then load that into the chart. So this is just a function that does all that, so we can pass it multiple things and reuse all that code. So now we're just going to define some date strings. So everything is going to be in standardized ISO 8601 format. So it's just year-month-day. And so this is today's date. We're getting yesterday's date by subtracting 1 day from it. And then last month's date. So when we do the monthly stuff, we can get last month. And then converting those to a string. So this is So now we're going to set the parameters. So these are the actual, this is how you define the data set for identifying which map you're actually looking to download. So this first one is temperature. Temperature has an aggregation because there's the min, max, and mean temperature, so how it's aggregated. The period is day. We're going to do daily temperature. The date, so this is going to be for yesterday. And then the extent, because you can get, there's for each county as well as statewide. So this is going to be a statewide data set. And then it's just going to pass all of that with some just header text to that display raster function. And then there's a couple others that are just other data sets. So the second one is going to be the rainfall data set with production new. So there's new and legacy. Legacy is that large data set that goes back to 1920, but is only monthly. So this is going to be the contemporary monthly rainfall for last month. And then for Oahu. So O is shorthand for Oahu. And then one last one, which is going to be relative humidity. So these are kind of the three main like time series based data sets that we have right now. So there's daily data for that for yesterday for the Big Island. So if I run that, it's going to pull the data for all those. These are the API request URLs that it constructs based on those parameters. So as you can see, it takes all of the stuff in the parameter object and converts it into URL parameters. So data type equals temperature, aggregation equals max, period equals day, the date, and the extent. And then it puts it on that endpoint, the api.hcdp.eqi.org/raster endpoint.
Jared, sorry, there's a question in the chat from
Oh.
Rich. He's asking how can he georeference the data ruling from the URL open method?
Oh, sorry, that should be resolved.
Sorry, what?
Yeah, if I want to,
I'm not sure.
if I want to be able to plot it, knowing the lat-long coordinates or an XY space, right now you're just plotting the image itself, but it's not georeferenced. Is there a way to get the georeference information?
Yeah. So I don't know how to do it off the top of my head, but what this is returning is a GeoTIFF file, basically. So
okay,
everything
so
is
the
stored as
transform
GeoTIFF.
should be in there?
Yes.
Okay.
The header of the GeoTIFF file will have the transform and all the geographic indexing data.
Okay, great. Thank you very much.
That GeoTIFF will lay down on any mapping program and work. You don't even need it. If you're trying to pull it into a mapping program or pull it into a coding program that reads a map object, the GeoTIFF, you could load the GeoTIFF and it's already georeferenced.
Yeah. Yeah. I want to be able to interpolate it to watershed boundaries. So yeah, I just need to be able to read it into like X-ray or something like X-ray.
Yep, you should be able to read that.
Yeah.
Thank you.
You can also write out to a file, and then you'll have that file available on your machine to use.
Oh, great. Thanks, Jared.
Yeah, so these are the three URLs that I generated, and then these are just the maps of them. So first one, maximum temperature for yesterday, and this is for the entire state. The second one is rainfall for Oahu for last month. So this is the monthly rainfall. And then the third is relative humidity for yesterday. So the next thing that we're going to do is a station query. So we're going to get a time series from the stations. So the stations are in a bit different of a format than the rest of the API calls, because this actually goes through the TAPIS metadata service. So this is essentially generating a query to a Mongo database that's run through TAPIS, which is a set of separate APIs created by the Texas Advanced Computing Center that we use to store all the station data. So this has a couple different functions that's going to go through. It's stored in a couple different pieces just for storage, saving on storage size. First thing is all the station metadata is stored with this special keyword name. And then it's going to generate basically it's going to generate a JSON query based on the information that we pass it. For the station metadata, this is just querying all of the information with this keyword name because we're getting all the station metadata. And then we're going to package this into just a dictionary object based on ID so that we can reference it against the values that we get and combine them together later. So for the actual station queries, this has the name of, this is going to have a special keyword name as well, and take the set of parameters that we pass into it and create a query by generating a string out of that object, that dictionary object. And then limit and offset, that's just if you want to limit the number of documents that are returned. Default's 10,000. We won't be getting more than that, so that should be fine. And then, so this is going to the stations endpoint. So that again is going to be appended to the API base URL. Going to perform a GET request for that. And then it's just going to do some manipulation on the returned objects to just get the result field from those, which are the actual value objects that we want. Then return the result from that. Then the final thing kind of puts these two together, where it's going to get so these HCDP station values with so it's combining, it's getting the metadata for, actually, I think we get the metadata down here, sorry. So the metadata is going to be retrieved first, then passed into this function. Then it's going to query the stations and combine the metadata. So each individual value object has the metadata in it since they're stored as separate objects. But that's going to do. So we should just be able to grab the metadata for all the stations. This is the values that we want. So we're going to get rainfall, the new production method, monthly rainfall, partial filled. So there's different filling techniques that are used. Partial filled is the most common one. We're just going to use that. And then for last month. Run this through the get station data, combine it with the metadata that we got. And then this is just going to create a plot of that data. So if I run that, this takes all of the station data from there and plots it out on the map. Like I said, this is creating basically a URL encoded JSON query object for Mongo. We're actually planning on creating abstraction away from this that's more in the style of the other HCDP requests where it has, it's a bit cleaner, but right now, since this is going directly to Tapas, this is how it's arranged. And yeah, then this is just plotting it on a map. So each of these points is a different station. And if you hover over it, it gives the value. So next, we're going to go over how to create a time series for a specific station. So there's two different time series endpoints, one for getting station data and one for any arbitrary location on the map. So if you give it a random latitude and longitude, you can get a time series for that location as well. So this first one is going to create a time series for a specific station, So this is just getting the first station from the last one. So instead of specific station, although what you can do is you can pass this station ID, which is at SKN, and that'll get a time series for a specific station instead. And then this is going to be for the last year, so creating a previous year string. And then this again is going through Tapas, so it's doing forming a query, which is, so this is greater than any value that's after any date value that's after a year ago, basically. And then for this data set. And then this is going to create a little plot for that. Yeah, so this is the last year of data for this station, 1146. So this is going to be the arbitrary map location, so the virtual station time series. So similar thing, except this is getting rid of some of the extra Tapas stuff where we can just pass it a latitude and longitude, the data set that we want, and then extent. And this will, again, generate a little plot with that information. And this is, yeah, kind of back to the other format where we just have each of the parameters as URL string or URL parameters. And then this is the daily maximum temperature for that specific location. So the last two endpoints I'm going to go over are how you would create download packages from the API. So the first one is going to be this instant content endpoint where it will immediately download the data package. And then the second one will be this email endpoint where it'll email the data package to you. So this, we're going to define what data we want to download. So again, the data set that we want, so daily relative humidity, statewide extent. This has a date range because we're downloading a range of data. This is station data, so it has this partial filled element. And then what file we want to download. So this is station data. The gridded map products have a bit of a different setup just because it doesn't have this fill parameter. So this is basically the same thing, just without the fill parameter. And then we're going to download the data map, which is that gridded data product that we have up here. So these maps. And then the metadata. Generally, it's good to download the metadata with it because that's, yeah, it's good to have. And actually, the GUI forces you to download the metadata if you download the data map. Then, so the parameters are, this is a post request that we're performing. So this is going to actually be the body, the request body. So we have to put our email address. And for this one, because it's not sending it to an email, this is just for logging purposes. And then the data, which is what data we want to download. You can also add other objects in here. This is an array, so you can download as many definitions of different data sets and time periods as you want at once. And then it'll save it to data.zip. So if we run that, it'll take a second for it to generate the download package and then return the contents of the download package to you. Usually it would be a bit faster probably, but there's probably a lot of people running it as well. So it'll be a bit slower, but it's done. So if we look, Google Colab has a little context that you can save files and stuff to. So if you go there, look in there, you can actually download that data onto your local machine because this is within the Google Colab context, and it should download that data. And while that's downloading, oh yeah, here we go. Okay, so this is, yeah, the data that we requested, relative humidity, daily, statewide. There's the partial field data, or station data, which are CSVs. And then there's also the data maps and metadata for the range I'm describing. So now you can also do the same thing, but have it send it to your email address. So this is especially good if you have a very large set of data that you want to download. So if it's taking a long time and you don't want to just wait for it to complete. So this is just the last year, but let's say we want all 30 years of daily data for something. It's going to take a while for it to generate the data package. So what we can do is we can just run basically the exact same thing, although instead of the instant content to this email endpoint. And what that will do is it will immediately return and just say it's generating your request. And then in a few minutes, it'll send an email with that data package. So we'll give it a second to generate that, and then I'll show the email from it. So those are the main endpoints that can go over in here. There's some other endpoints as well as a number of Mesonet endpoints that are all available in the API documentation, which there's a link to if you go to the HCDP, there's a form that you can fill out to request an API token, and that has a link to the API documentation there as well. So you can go through that, and there's different endpoints. Everything that happens on the front end of the HCDP, that GUI, is all essentially going through this backend API. So this is, yeah, you can do it programmatically, but this is also how the website works. And I think we're going to go over a couple, just a couple exercises now where you'll take some of the things that we ran through in this workbook, and you can make small modifications to try and get different data sets. So I think Matt has the information for that.
So I guess we'll just jump back and forth on screens really quick, Jared, but we'll just use my screen to show everyone what we'll show everyone what the exercise is, and then we'll jump to your screen, let people figure out, try to struggle and do it. And then we'll, jump to your screen and you can show them how it's done, and I'll show them some of the outputs as well, or vice versa. So
yeah,
okay,
sounds good. I can run through and do all of it.
I'm gonna replace. Okay, so the first exercise is, this. First API exercise is, let's try to create a data package of gridded maps and metadata for the past 3 days. So January 21st, 23rd, of daily relative humidity for Oahu, and download immediately. So I think this first one, Jared, why don't you just take the screen from me and you just show people how to do this one right away. So just basically be like another example, but Jared is going to show you how you can kind of use the notebook that he has and change the different variables in the notebook to get what you need to get this data request. So go ahead, Jared, take my screen and go for it.
Okay, so let's see. Let me pull up the text for the exercise so that I know what to do. Okay, so we're going to, this is creating a data package and downloading it immediately. So this is going to be the second to last cell where we're creating a data package and downloading it, the instant content one. So we're looking to do a date range from 2025-01-21 to yesterday. So we can leave this yesterday string there because that's the endpoint. So this is going to be daily relative humidity, which is already there. we can update the extent. So this is, yeah, we're going to do it for Oahu. So that would be OA. And then, so this is the gridded data map and metadata. So actually this isn't needed. And we're going to be downloading, these are the two file types that we're going to be downloading, is this data map and metadata. And then we can download or remove the second one because we're just downloading that. And I believe that should be everything. Oh, whoops. Forgot to put quotations around this. That's why it's, there we go. Okay, so now if we run this, should have overwritten this. Yeah, so this is daily relative humidity data for Oahu. And then this is just the last 3 days. So January, and then, yeah, the 3 days that we requested.
Great. Okay, I'm gonna share the next one. I'll put it in the chat. Where you can just stay on, Jared. We'll let people. So exercise 2, it's in the chat. Create a data package of gridded maps and metadata for the past 21 days. The date ranges are there. Of daily relative humidity for Kauai and have it send to your email. We're gonna give people like 5 minutes to kind of do this. And then Jared is gonna share where. Maybe Jared, do you want to give a hint on what block of code the title of the block of code they should be editing?
Sure. So that's going to be the last block of code, but that does reuse the data from the one before it. So it's going to be that same data set that we're going to be modifying, but you'll run the last block of code instead.
Okay, Jared, go ahead and
Okay.
share the solution. Or if anybody's got any specific questions or hangups, otherwise Jared will just let you know.
Okay,
go
so
ahead.
similar in the last one, we're going to replace the start date, this time with 21 days ago. So this is January 3rd, 2025. And then this is still daily relative humidity, so we can leave that as it is. The extent for Kauai is Ka. And it's still going to be the data map and metadata that we're looking for. We can comment that out because we aren't running that part, but we will have to run this just to set all of those variables. Then now if we run this last block of code, it should generate the data package for that and send it to our email. So if we wait a moment, it should come into my email. This is the last one that I generated, but it'll take a second for it to create that.
Great. Any questions on the chat or anything? Okay. Okay, we're gonna move on to the third one. So the third one is in the chat. HCDP API exercise 3, display a map for Oahu with daily minimum temperature data for yesterday. So that's January 23rd. Pretty cold on Oahu yesterday. So we're gonna wait to give you any hints or anything and just really let you struggle. And then Jared will give the answer here in a little bit. I stole the screen back from you, Jared, but we'll jump back over to you when you explain how to do it, okay?
Okay.
So while you guys are still working on it, I will show you, this is what the map actually looked like. And just to highlight, it's 50 degrees in the top of Mount Kaala. It was like 58, 56 in Wahiawa, and like 62, 63 down in the water in Honolulu. It's pretty cold. Okay. Go ahead, Jared, take screen.
Okay. So to display the maps, we're going to go back up to here. So we still have our function defined for doing all of the details for that, but what we are going to want to modify is the data set that we're looking for. So this is going to be daily minimum temperature. So this one already has temperature, so we can modify that to min for minimum temperature, and that's going to be for yesterday, so that's already set. And we're looking for Oahu. So we're going to change the accent to OA. And we can comment out the rest of this so that only displays that one. And then we can just change this text. So this is, minimum temperature for yesterday. Then if we run this, should generate that map.
Great. Okay. The last exercise I'll put in the chat right now. Second. Okay, exercise 4. It's the last one. Create a time series from 2018-01 to 2018-31 of daily rainfall data for a location north of Hilo at latitude 19.7892, longitude -155.0942. So this is extracting values from those 31 maps at a location and plotting it into a time series. So you know that month was the month that Hurricane Lane did a close pass to the Big Island, and several of its rainfall bands impacted the. So we should see a rainfall spike during that time at that location. Okay, before Jared gives you the full answer, this is the time series, what the time series will look like. So you can see this huge spike here getting over 300 millimeters of rainfall. And that was Hurricane Lane. So Jared, take the screen from me and why don't you show people how to edit?
Okay, so if you go down to this block where it's create a time series for an arbitrary location on the map, so we can replace the latitude and longitude with the ones that were provided. Then we're going to change the data set that we're using. So this is daily rainfall. So rainfall, then production, new daily rainfall. Okay, so we set the start and end dates to the period that we want. We have a specific latitude and longitude that we're using, so the extent doesn't really matter. You could set this to the Big Island if you wanted to, but that's not really important because it'll be the same location on either one of the maps.
Would it cause an issue if you put the extent to the wrong, like to Maui, and that was outside of Maui? Would it give you? It would probably give you an NA, correct?
I think it will give you an empty map, and we can try that. Let's see.
Well, do it correct first, and then
okay,
we'll.
okay. That makes sense. Okay, so if we run this, yeah, so this is the rainfall, daily rainfall for that location for the month. And yeah, as Matt said, huge spike during Hurricane Lane.
Great. Okay, yeah, why don't you change it and let's just, this is learning for all of us. Why don't put in Maui and see if it returns no data. Yeah.
Yeah, it's just
so if you have a point location in this using this functionality and you know that it's on an island or within a county, you can use either that county extent, or if you want to be safe, you don't know where it is, you can use statewide extent and it will return a statewide. The same thing would probably happen if you put a point that was off into the ocean or something like that, where there wasn't any rainfall data. So
yeah,
just something to keep in mind. Okay. Thank you very much, Jared. We're going to switch back to the presentation now. So, yep, we got the hurricane. So we went through all of the API stuff, and now we're at the last little bullet in our agenda, which is HCDP resources, survey, and questions. So there's a survey. Can we put the survey in the chat? So surveys in the chat. You could probably scan it with your phone right here on the Zoom and be able to get to it too. But it would be great if you could fill out that survey, open it up as a tab if you can't do it right now, if you need to take notes somewhere or something, but it'd be helpful for us to have reporting on this. And it also improves the experience of these workshops going forward and improves our experience of people that we're training with the Hawaii Climate Data Portal. So that being said, I'll let the survey stay up there for like a few more seconds. Also, the link is in the chat. Is there a follow-up email that goes out to Shivani? Or no?
Not at the moment.
Okay. Okay, great. Okay. Everyone, hopefully it's open up the survey tab. So that being said, let's open this up for some questions. I also, just so that you know, there is my email, Carrie's email, and Jared's email there. And on the last page here, there is a link to the Climate Data Portal, which is just a standard Climate Data Portal, the landing page that I showed you in the beginning of this webinar. And then there is below this Mahalo, there is the sign up for the API. So if you want to get your own API token, if you want to keep coding using this, because the token that Jared put on will probably only work for a little bit longer before you start to get errors with that token. That being said, there's the resources for that. But yeah, is there any questions? In the chat or just speak up, I guess, right? Yes.
I think earlier when you were presenting, you mentioned that the mean temperature is not derived from the station. So it's not measured, is that correct?
Yeah, so we don't get actual daily station data of the mean temperature. So that's calculated from the maps of impacts and everything.
Any other questions? Okay. I will put this in the chat.
I have maybe a stupid question.
Yeah, go for it. No stupid questions.
Is it possible to do the same API but through R, or does it have to be through Python?
Yeah, I've used it through R. So the way that Jared was constructing, so when he was in those examples, you can see those URLs that were being generated. You can do the same kind of create the same URLs using R.
Okay.
So we don't have an R notebook quite yet, but it's something, I'm kind of the R specialist on the team. So maybe that's something I can work with Jared on doing, and we could put this up and share that with you.
Okay,
So
cool.
you should do a follow-up email to myself or to Jared, just being like, it would be awesome to see some R examples, and maybe we could just we probably wouldn't do like as big of a notebook, probably do something smaller to be able to figure it out, but yeah. So
Okay.
yeah. Okay, there's the API sign up if you want the API. And if you just want to go to the climate portal, you can pretty much, the URL ending at portal will get you there. So, okay. That being said, thank you very much for coming. And yeah, I think that'll conclude. Correct? Yeah.
Thank you all.